section 1.4, applications and modeling with quadratic equations. Now that you've learned how to solve a quadratic equations, we're going to use those in application problems. But before we get started, I wanted to remind you that on your calculators, in order to solve a quadratic equation, you probably have a program that will help you solve them. Remember to check under your program list, and you can check for Quad 4 program, and it will solve any quadratic equation that is in standard form. This will be very handy on our application problems. All right, so I'll put that aside. Now, to solve an applied problem, first thing you're going to do is make sure you read the problem carefully until you understand what is given and what is to be found. Assign a variable to represent what you do not know. Draw a picture if you need to. Write down what the variable represents. And if necessary, express any other unknown values in terms of the variable. Make sure you write an equation. Then you're going to solve the equation. These will be quadratic. And then once you find the answer, think about it. Does it make sense? And make sure it solves the problem. Make sure you answer the question that they ask. The first type of problem we're going to look at is called a geometry problem. A picture frame has a length which is 5 centimeters more than the width. The area enclosed by the picture frame is 104 square centimeters. Find the width of the frame. All right, I circled area because that's one of our key words. We have a picture frame. All right, so a picture frame obviously is going to look like this. This is a rectangle, and you remember that in order to find the area, you need to multiply length times width. So, what do we know in this problem? All right, a picture frame has a length which is 5 centimeters more than the width. Well, this looks like the width. I don't know what it is, so I'm going to call it W. The length is 5 more than the width, so the length would be width plus 5. 5 more than the width. Now we know that the area is length and width. This is length times width. So length and width multiplied together equals the area, which is 104 square centimeters. Now this is a quadratic equation that we know how to solve. We're going to use our distributive property to get rid of our parentheses. W times W is W squared, plus W times 5 is 5W, is equal to 104. Remember, you have to put a quadratic equation in standard form, so let's subtract the 104 to the other side. W squared plus 5W minus 104 equals 0. Now this is a quadratic equation. We can use our quadratic formula in our calculators. Remember, in order to use that, you need to know what your A, your B, and your C are. The A for this problem is the coefficient of your W squared, so the A is 1. B is the 5, the coefficient of your W, and the C is negative 104. We can put this in our quadratic formula. So here's our quadratic formula. Our A is 1, our B is 5, and our C is negative. Remember to use your negative sign, not your subtraction sign. So negative 104. Hit enter. And since it's an application problem, let's just go ahead and hit enter one more time, and we get two answers. We get a negative 13 and an 8. So we got W is negative 13 or 8. All right, so now we've solved the equation. We've done step 4. Now we have to think about our answers. Do these seem reasonable? Look at these answers. One of these is negative, one of them is positive. W stands for width. Can the width of a frame be negative? No, it can't. So we're going to throw that one away. And we are left with W is equal to 8 centimeters. The last thing you need to make sure is, did you answer the question? The question said, find the width of the frame. This is the width of the frame, and this is our answer. Okay, our next problem, another geometry problem. The area of a rectangular wall of a barn is 36 square feet. Its length is 6 feet longer than twice the width. Find the length of the wall. All right, again, area of a rectangle. So we know area is length times width. Let's draw our picture. All right, here's the wall in the barn. The area is 36 square feet. So we know area is equal to 36. So we needed expressions for length and width. So let's read this one more time. Its length is 6 feet longer than twice its width. We don't know the width, so let's call that W. The length now, this side right here, is 6 feet more than twice the width. For twice the width, that's 2W. 6 feet more than that gives us 2W plus 6. Now we know area is length times width, so we're going to have our length and our width multiplied together to get 36. Now again, we're going to solve the problem. We've got to get rid of parentheses, so use your distributive property. 2W squared plus 6W is equal to 36. We've got to put this in standard form again, so subtract the 36. So 2W squared plus 6W minus 36 is equal to 0. And again, this is quadratic, so we're going to put it in our quadratic formula. So A is going to be 2, our B is going to be 6, and our C is going to be negative 36. When we put this in our quadratic formula, once again, here it is. Our A is 2, our B is 6, our C is at negative 36. Make sure you use the negative 36. Hit enter one more time, and we got two answers again. We got W, which is our width, is equal to a negative 6 and a 3. Again, are these answers reasonable? What about this negative 6? No, we are talking about a wall. A wall cannot measure negative 6. So we got that width is equal to 3 feet. Okay, that's an answer, but is it the answer to the question? Let's go back. Find the length of the wall. What we found is the width of the wall. So how do we find the length? We know that this is the length. So we know that W is 3. So our length is going to be 2 times 3 plus 6. That's going to be 6 plus 6, which is 12. So our answer is that the length is 12 feet. Now, while geometry problems are fresh on your mind, you ought to pause and work problems 1 and 19 from your ebook. Remember to check your answers. They are in the back of your book.